So now we're going to look into our fifth learning outcome, which is logarithmic differentiation. So recall back in semester 1, we learned what are logarithmic functions. So logarithmic functions are basically functions that has an index as the power. So therefore, example, if you need to differentiate y equals to 2 to the power of x plus 3, you can't differentiate it straight away. You need to actually introduce ln, which is logarithms, on both sides of the equation. So remember, when you introduce ln, you need to introduce ln to both sides of the equation. So for example, for this question, you have ln y, and then x plus 3 is the index. So when you introduce ln, you can actually bring it to the front. So it becomes x plus 3 multiplied by ln 2. Next, what you need to do, you need to just differentiate it, applying all the rules that you have learned, including the implicit differentiation, because there is ln y here. So recall back, to differentiate ln fx, it is f prime x over fx. So similar here, f prime x here is dy dx. If you differentiate y, you get dy dx over y. So I've wrote it in a way 1 over y multiplied by dy dx. Okay, so each time you differentiate ln y, you will get 1 over y multiplied by dy dx. Differentiating this gives you x plus 3 ln 2. Ln 2 is a number, is a constant. So therefore, in order to differentiate this, it becomes ln 2x and 3 ln 2. So differentiating ln 2x gives you ln 2. Differentiating 3 ln 2 gives you a 0 because it's a number. Okay. So in order to get dy dx, you need to collect the terms together on the right. So therefore, this becomes ln 2 multiplied by y. And you need to differentiate with respect to x. So therefore, you need to substitute your y in terms of x back into this dy dx. So y is 2 to the power of x plus 3. So you need to substitute y as this over here. So this would be your final answer to determine the dy dx. Next, we'll look into the next example. If you require to differentiate y equals to x to the power of x. So if there's an index, you need to introduce ln in order to differentiate. So it becomes ln y equals to, bring the index in front, so x ln x. So in order to differentiate ln y, again, as explained in the previous example, ln fx is f prime x over fx. So f prime x here is dy dx, because differentiating y gives you dy dx over y. So it's 1 over y times dy dx. This one is x ln x multiplied by ln x. There are actually two different functions, which is x and ln x. So it's u, v. You treat to differentiate this as a product rule. So differentiating x gives you 1. You copy your ln x plus copy x. And differentiate ln x is 1 over x. So x times 1 over x gives you 1. And then you bring the y over to the right. It becomes y multiplied by ln x plus 1. And remember, you need to differentiate with respect to x. So you need to substitute your y with x to the power of x over here. Now next, we will look at the third example, which is differentiate this. So now this function, you have two options to differentiate this. You can either use the quotient rule, or you can apply ln or introduce logarithms in order to simplify your differentiation process. So here we're going to see how we can apply ln to make it easier. So you see here, this is as if it's y a times b over c. Yeah, so you can introduce ln. It's like ln a plus ln b minus ln c. Recall back, when you divide, you actually minus the ln. So for example, ln y equals to half ln bring the index in front, yeah? So half ln 2x plus 1. Because it's multiplied, so it becomes plus 2 over 3 ln 3x minus 1. And then minus, because it's divide, 3 over 4 times ln 4x plus 3. So this is how you introduce ln. Then you differentiate each function individually. So 1 over y divided dx is the product of differentiation of ln y. Differentiating this gives you 1 over 2 multiplied by, when you differentiate ln fx, it is f prime x over fx. So it is 2 over 2x plus 1. So half, it got simplified. You'll get half multiplied by 2 over 2x plus 1. So therefore, it will simplify to 1 over 2x plus 1. 2 over 3 multiplied by 3 over 3x minus 1. So therefore, it will reduce to 2 over 3x minus 1. Minus 3 over 4 multiplied by 4 over 4x plus 3. So it will become 3 over 4x plus 3. Next, you need to get a common denominator. So therefore, you bring the y over, and this one you're going to work out to get a common denominator. So in order to get a common denominator, you multiply all three factors together. Okay, this is basic algebra, yeah. So 1 multiplied by 3x minus 1 and 4x plus 3. 2 will be multiplied by 2x plus 1 and 4x plus 3. 3 should be multiplied by 2x plus 1 and 3x minus 1 over the denominator will be product of all the three factors. So work this out and simplify this, and you will arrive to this answer. And you substitute your y with y in terms of x from the question. So this will be your final answer after simplification. Okay. Please work on the simplification, the nitty-gritty of the algebra, and make sure you arrive to this answer. Please work on this. If you have any questions related to the simplification and so on, you can post it on the Padlet link provided in the e-lecture folder for this chapter.